Hello, everyone. My name is Krista Kennard, and I am here to talk to you today about how AI can enable data-driven decision-making, especially in the federal government context. I know the theme of today is specifically looking through how we can use data and artificial intelligence in times of emergency and for emergency response. So I'll specifically be speaking to kind of how do we use data in those situations. I am a director at the Artificial Intelligence Center of Excellence, and I'm really honored to be here today. So first, I just want to level set. It looks like the slides aren't progressing along, but I just wanted to level set to talk through our agenda. So first, I want to talk a little bit about TTS AI and what exactly is the Artificial Intelligence Center of Excellence. And I want to specifically talk about who we are and how we are empowering government to really be adopting artificial intelligence. And then I want to talk a little bit about applications of AI in government and really how AI can be that enabling tool to really help government meet its mission. Not just during times of emergency, but always, but I think especially during times of emergency. And then I want to talk a little bit about what does it take to get to that level of success, right? What does that roadmap look like? And how can we work together to get there? So we can go ahead to the next slide. So TTS stands for the Technology Transformation Services. So broadly, we sit within GSA, right, which is, I think, a really good place for TTS to sit because we have a government-wide focus. And what we do is we engage with the rest of the federal government on topics and on innovation, right? So we engage with the federal government around IT modernization, ranging from cloud and infrastructure, right? And data transformation and customer experience, right? Really any kind of thing that you're thinking about in terms of IT modernization, that's really something that TTS focuses on. And we really kind of have these different focus areas in which we target our work, right? So that we can scope it into something that is palatable. And so one of our focus areas is artificial intelligence, right? It's one of our newer focus areas, and it's one of the areas where I am helping lead. So broadly, we have our mission in TTS, not just to advance IT modernization and innovation, but specifically in artificial intelligence. TTS AI is here to support and accelerate the adoption of artificial intelligence within the federal government. And so I realize that that's a really broad message, right? And sorry, it looks like we're having maybe some technical difficulties, but it's a really broad message. And so we've kind of broken this down into a couple of different ways for us to be able to interact and engage with the federal government. So kind of high level, one of the things that we really are driving to do is create a community for sharing best practices and lessons learned, right? I think as a federal government, it's really easy to get stuck in our silos, to get stuck in just our mission, head down, kind of driving through. And it's really hard sometimes to pick our heads up and look across not only our own organizations, right, to say, what's happening in this other arm of my organization? Or I'm sitting in this area of the org chart on my organization. What's happening in another area of the org chart in my organization? And then it's even harder to come up the next level to say, all right, I work for one agency within the federal government. We know that technology and innovation is really a priority across the federal landscape, right? So how can I hear what other agencies are doing to drive innovation, to drive adoption of artificial intelligence. And so here at TTS, because we are at GSA and we do have that kind of government-wide perspective, that's where we're really able to bring people together, help people get out of their silos and share broadly, right? What are the best practices that we're seeing in artificial intelligence? What are some of the lessons learned that we've seen across government in terms of doing some prototyping, doing some piloting, building out data infrastructure, right? Because at the end of the day, we're not in this alone, right? And we want to be able to learn from each other so that we are all able to reach success. The second thing that we're really pushing on broadly within TTS AI is fostering and supporting learning and education for the federal workforce on these topics of artificial intelligence and data infrastructure, and the kind of the things that go along with that. And the reason is, right, there's so much happening in this space, and innovation is moving at the speed of light, right? And so making sure that our federal workforce is skilled and really up to date on what is this technology and how it can be a value add is really important. And so one of the things that we're really pushing on is how can we make sure the federal workforce knows what they need to know about this as an enabling technology? And that's really one of the things that we're building out. So the other side of that is our centers of excellence. Broadly, our centers of excellence sit in a part of TTS that directly engage with government, right? So TTS AI is this convening mechanism. We have conversations, we bring together community. Whereas the centers of excellence, that's where we partner one-on-one with agencies to be able to drive innovation and adoption, right? And so we do that in almost a consultative type approach, right? And so this is really where we're not just talking about AI, we're not just thinking about AI, we're actually doing AI as well. And we are helping agencies not just think about their strategy, not just think about what should we be doing, but actually taking strides to reach their goals in terms of data infrastructure and artificial intelligence. And we do that in a couple of different ways. First and foremost, the Centers of Excellence takes a human-centered design approach. Artificial intelligence, I think, is a really fascinating technology, but I think we can all recognize that if we don't do it in a way that is responsible, if we don't do it in a way that is empowering people, right, we're not doing a good job, and we're not doing it in a way that is truly going to help agencies meet their mission, right, and provide value and deliver those services and protections that they deliver. And so humans are at the focus of what we do, right? And it's really about using AI as an enabling tool to allow the people who make up our federal workforce to be even more empowered and to be even more enabled to do their jobs effectively. We also do this through rapid prototyping, right? The iterative development nature of artificial intelligence lends itself very much to try something. If it doesn't work, change direction. If it does work, try again, right? So we do very quick prototypes to be showing incremental value. And then the other big thing that we do is capability assessments and implementation, right? So I think, and we're going to talk a little bit about this later on, but one of the hardest things about artificial intelligence as an enabling technology is being able to understand where your organization is at right now, where it could be, and how do you fill that gap, right, from where you are to where you want to be. And that's absolutely a service that we are able to deliver on at the Centers of Excellence. So let's go ahead and move on to the next slide. So given our experience as TTS AI and as the Centers of Excellence across the federal government, we're starting to see a lot of really great applications of AI. And I think some of the biggest areas that we're really starting to see that is to drive outcomes, right? So increasing speed and efficiency of a specific mission area focus, and I think that this is really an important use case for AI, right? Not just for mission delivery, but taking that step back for mission support, right? And being able to use artificial intelligence as that supporting mechanism so that people can actually be focusing on delivering the mission that they're really passionate about. Cost avoidance and cost savings, right? A lot of these very manual and arduous tasks that are happening right now can be very expensive as well. So using tools like artificial intelligence can really help us with that cost savings element. Improving response time, right? This is a really important application of AI because we live in a digital world, right, where people have technology at their fingertips, right? Being able to interact across the government and also with the communities that we serve rapidly and effectively is really something that artificial intelligence is starting to help out with. And then, of course, increasing both quality of the mission we are able to deliver on or the mission support services we're able to deliver on, and increase compliance, right? Providing that level of standardization and guardrails really is a really great application of AI. And I think that these are really important, especially in the time of emergency, right? Because first, of course, in times of emergency, speed and efficiency is incredibly important, but you don't want to sacrifice quality for that speed and efficiency, right? And you'll see on the left-hand side of the screen here, all of the different ways we are seeing kind of these 4 elements of artificial intelligence being implemented, right? So things like simplifying regulatory and compliance processes, digitization and automation of forms, right? And I think as anyone who has worked in any kind of emergency situation with the government, forms are a really critical way that the government moves information from one area to another, right? From end users to the program office that should be processing it, across different offices to be able to process any kind of request. And so using artificial intelligence to increase our ability to process those forms is really, really powerful. Intelligent assistants and chatbots, right? I mean, I think that there's application across the federal government in terms of our call centers, right? And even creating intelligent call centers, right, is something that we can be really delivering value on. And I think that one of the things that we focus on with emergency response is, when is it appropriate to have some kind of chatbot or artificially intelligent call center being interacting with folks? And when do we really need to have that human touch, right? Because there are times when you do need that human level of interaction, but there are also times when we can really use artificial intelligence as a tool to enable those human interactions. Things like fraud identification and prevention, right? Which I know is another really important element of responding to emergencies like we're in now. Another huge one, right? Increasing video and social media analytics in terms of how are we responding to people? How are we able to meet the needs of the folks that we're interacting with, depending on what our mission is? All of these are, I think, really important applications of artificial intelligence. And I think that the reason I like to talk about these specific use cases and these specific opportunities to be using artificial intelligence is because emergencies can happen at any time, right? Like, that's kind of the nature of an emergency. And sometimes we can plan for that, right? And sometimes we can look to past experience and say, these are problems we have had when we have had to quickly mobilize and quickly scale a specific program or product that we're trying to deliver on. How can we prepare for that in the case of an emergency? And then the other side of that is, a huge part of living in an emergent time is sometimes you are building the plane as you're flying it, right? There are so many unknowns, and it's hard to prepare for those. But if we can prepare for those known unknowns and create the infrastructure to support what would happen in an unknown situation, it makes it so much faster and palatable to actually deliver and meet those unknown unknowns when they come up. So let's go ahead and go to the next slide. And I want to talk a little bit about, all right, so for artificial intelligence, what does that success look like, right? What does it mean to say we have our artificial intelligence shop set up? So if there's an emergency tomorrow, or if there's an emergency today, right? This is how we can make sure we are able and ready to handle it using artificial intelligence. And the way to do that is to set up an artificial intelligence pipeline to be able to drive the outcomes that you're looking for. So really being able to have a defined and streamlined path to get from the business need or challenge to that enhanced business delivery, either in blue skies time or during an emergent time. So let's dive a little bit deeper into that, right? What does that look like? Well, so first of all, you've got to really be able to understand what your business needs or challenges are, right? So having infrastructure to support identification of use cases, right? Defining the evaluation criteria to say, is this use case that's come up for either an emergent or non-emergent situation, how palatable is it to be able to go forward with it? How feasible is it? How realistically could we move forward with it? And then I think another huge part of this is you really have to be starting to identify who are the champions who are going to be able to make this possible in your organization, because technical infrastructure alone is not going to make that happen, right? And as you start building out, kind of getting to success, that means you're able to really look at how do we evaluate AI as a technology? Are we going to make it in-house? Are we going to buy it, right? So having that infrastructure to be able to identify when do you make, when do you buy, right? Identifying funding sources for your proof of concepts or for your pilots, right? If all of a sudden tomorrow some emergency happens and you say AI is a great solution for this, how are you going to be able to say, yes, now let's pay for what we need to build, right? If you also have to be looking for that funding mechanism while you're trying to figure out what the solution is, you're adding time and complexity that really could be prepared for in advance, right? A successful kind of that successful infrastructure also has the ability to move from dev and test environments to production, right? How can you make sure that the DevOps associated with having to build out your AI solution is going to be able to go smoothly? And then something that is really, really near and dear to my heart is how are you going to test and evaluate whatever it is that you build so that you are sure that it has the impact and the outcome that you are intending, right? The absolute worst case scenario would be to build something very quickly because we're under a lot of pressure in an emergency situation that ends up disproportionately affecting people or having unintended consequences. So making sure you have that evaluation and test criteria set up ahead of time is really important. And then finally, right, when we are getting to that business delivery element to it, right? Who's going to own this? How are we going to transfer it over to them? And how are we going to govern this solution as we've built it out? So I think that this is really it's not a pipe dream, but it's a dream for sure. And I think that not many organizations are really at this stage yet. So I just briefly want to go through, if we go to the next slide, a roadmap for how do you get there, right? And so the roadmap really starts with understanding the AI landscape, right? What are the tools, services, and solutions that are available? And then also understanding your mission pain points and problems so that you can identify where AI could potentially be a benefit, right? Might be able to provide that value that you would need. Once you've kind of gathered this understanding, then you can start moving into assessing your organization and starting to do that gap analysis, right? Assessing your organization's maturity regarding your technical infrastructure, right? What data sources do you have available to you? How are they housed? How are they managed? How are they accessed, right? Because there's no way you're ever going to be able to build an artificial intelligence solution if you don't have that data infrastructure kind of getting into place, right? So really being able to understand where you're at in terms of your data infrastructure is really important. And then also assessing your organization's maturity as it relates to your programs, right? Integration into your current workflows, buy-in from champions, right? Are people actually going to be able to use this and understand it in a way that's meaningful to them? And also, right, starting to assess, what does your acquisition process look like, right? Do you need to start briefing and priming your acquisition workforce on how do we buy this, right? How do we bring in the tools and services that we're going to be needing? Because it's not just going to happen overnight, right? So once you're able to do that assessment, then you can start prioritizing your investment, right? Investing in people, investing in those who can be those champions, who can make informed decisions about what you're buying and building, right? Investing in that technical infrastructure, right? Again, if an emergency situation comes along and you say, yes, AI can help us with that, it's going to be so critical to already have that infrastructure in place rather than having to build the infrastructure, then build the solution, right? And then also planning for funding, right? Starting to really figure out what are our budgeting priorities so that we can make sure funds are available for this. And then you can start to think about, all right, what does this build process look like? Selecting projects based on mission needs. Really trying to figure out what the AI development lifecycle looks like in your environment, right? And creating that organizational governance and policy. So again, when something comes up quickly, you can say, we already know what it's going to take to make this a success from a governance perspective. So we can go ahead and move to the last slide. So that's really all I wanted to talk about today. Thank you so much for your time. If you'd like to learn more about what it is that we're doing here at TTS AI and the Centers of Excellence and how you can engage and how you can get involved either at a community sharing of best practices level or specifically through an engagement, you can go to our website or you can reach out through email. Thank you very much.
Hello, everybody. My name is Tom Suter. I'm the founder of the Advanced Technology Academic Research Center. And we're really lucky to have a presentation from Christina Shao, Data Evangelist at Data IQ. How are you doing today, Christina?
Very well. Hope you're well also.
Great, great. And where are you from, Christina?
I'm based out of Charlotte, North Carolina.
Fantastic. Glad to have you today. I'm looking forward to your presentation. Thank you.
Thanks. All right, everyone. Nice to see you. As Tom said, my name's Christina Shao, and I'm an evangelist for Data IQ. Today, I'm going to talk for just a few minutes on why you can think about data science as a team sport and how Data IQ can help address some of the challenges associated with working on shared AI initiatives. So, if you will, imagine playing on a sports team where all the players on the field are simultaneously following their own individual interpretations of the game strategy. And each person's only making the moves that align with his or her own personal strengths that come to them naturally, but without a lot of coordination with the other teammates. So I can imagine that there'd be a lot of missed passes and failed shots and probably some pretty frustrated players and coaches. So let's see how we can use this analogy against data science. So from the outside, I think the perception of data science projects is that the teams are comprised of, no surprise here, data scientists. But actually, when you're working on shared data projects, we have a lot of different players. You have an analytics lead, a project manager, data engineers, business analysts, data scientists, and then you move into the ML and DevOps folks and so on. And so conceptually, the field may look something more like this, which makes sense. Different positions serve different purposes, just like in sports. But one of the most common challenges that teams face when they're working on these teams is difficulty coordinating with each other in a transparent and an efficient way. Now, sometimes that's because each person is working independently on the desktop with maybe local copies or samples of files. Maybe it's because some people have very deep domain expertise, but no formal data science training, and vice versa. Other times, the challenge is that you've got some types of teammates who prefer to use low or no code type of visual tools, and others really are a code first approach, dive right into the notebook, hands-on keyboard. And in the end, what ends up happening a lot is that each person has a really hard time understanding, much less replicating, what exactly other people are doing in their particular part of the work stream. So in all of these cases, the impact of these disconnects can lead to inefficiencies at best and lower quality outcomes and data products at worst. So at Dataiku, we believe that collaborative data science is not only possible, but absolutely critical to any organization who wants to scale AI. So by embracing the different strengths, technical skill sets that various contributors are bringing to the table, and allowing them, or really enabling, maybe is a better word, enabling them to consolidate their work in a governed and organized way, we can help ease these types of pains I mentioned and allow products, data products, to be developed both faster and more effectively. So what I'm going to talk about just for a couple minutes today is our software called Data Science Studio, or DSS for short. It provides, as you can see here, an end-to-end set of capabilities that allow your data analysts, data scientists, and so forth, many other profiles, to access data and wrangle and prepare it, to build and deploy machine learning models, and visualize and productionalize the results, or operationalize the results, you know, all in that single centralized platform I mentioned. So this is just a screenshot of a very simple example of the flow. This is the heart of a Dataiku project and the visual representation of a very simple pipeline. And what I want to mention is that DSS offers not only that guided visual interface for those who prefer to point and click their way through data tasks, but for those who do prefer to code, there's a full range of features. So things like code notebooks in a variety of programming languages, or code environments and APIs. Now, regardless of which path you choose, and with Dataiku, the choice between clicking and coding never needs to be entirely one or the other, all the transformations and logic are automatically documented and they're visible to everyone. So there's no more ambiguity about what's happening to data as it moves end to end through the pipeline. So you can think of this like having a built-in color commentator for you that happens automatically. So this is DSS, and we don't have much time to do more than just scratch the surface here, but I want to mention that despite the comprehensiveness of DSS as a data science and orchestration tool, some of our US federal customers' favorite features are not technical at all. Believe it or not, they're really about administration and security and about housekeeping. So they love the DSS features that facilitate collaboration and project communication and oversight by mission owners, even more relevant in today's remote working times. So there's a few good examples of collaboration features right here on the project homepage. So we can see here project tags that are searchable and all the different contributors. These are my teammates who are working on this particular project. Below, we see a robust description and explaining important context and project objectives. We have an editable to-do list where you can tag people, and an embedded chat feature. And this is handy because it keeps discussions about the project attached to the project rather than scattered across regular company or organizational emails and sideline chats. Now, mission owners and project managers can quickly come here to see the most recent actions that have happened on a project without having to ask, what did you do today? What did you do this morning? And over time, they can also see the contributions of team members. So really handy project management and communication features here. When a new team member joins the team, they might first go to the wiki to find out what's going on. How can I come up to speed? What's the background? Or they can go to the flow. I showed you this before. This is the visual representation of the pipeline. And you can inspect this and quickly see what's been done before. So from just looking at this one visual, I can understand from the blue square icons that I have data living in 3 different source systems: Snowflake, Hadoop, flat file CSV upload. It's easy to see from these icons that what the data analyst did was a series of manipulations. We have data preparation, stacking data sets, aggregations, and joins. And if I'm curious about what the data cleaning was, it's very transparent to me exactly what the cleaning steps are, and they're documented for me. Now, similarly, I can say, well, what did my data scientist do? And with just a couple clicks here, I can preview that code to see what my data scientist, what she added. And without knowing how to write a single line of code, I can easily go in and review maybe the machine learning model to understand what features were being used to help predict credit risk. Maybe I have some subject matter expertise and I want to contribute my thoughts on suitability of each of these features and how they're being handled. Or just for fun, we can go and maybe look at the results. Let's look at my home state. We'll pick North Carolina here. And I'm interested in seeing what were the most important variables in my state for predicting credit risk. So as a non-coder or a coder, I can quickly evaluate what my teammates are doing. Now, what I showed you are just a few of the ways that DSS can reduce the black box effect and help different personas seamlessly contribute to the same project and keep communication flowing. And in the end, this is the team dynamic, as complicated as it looks. This is the dynamic that we're really trying to foster, is all the teammates on the same playbook, doing their part towards that shared goal and hopefully a win. So we'd love to hear more about your experiences working on shared data projects and tell you more about DSS. So please visit the Dataiku virtual booth, where you can chat with our team and download content and request a demo. Thanks for watching.
Thank you, Christina. I enjoyed that presentation. That was Christina Shao, Technical Evangelist at Dataiku. Thank you.
Thanks, Tom.
And now on to the rest of the programming. Thank you.
Thanks, Tom. So next up, we're moving into the first track under the AI and data. Thank you all for joining us and choosing to join this track as well. It's going to be interesting. We've got a great lineup of speakers we're going to get started with just shortly. One reminder, though, we are going to save some time toward the end of this conversation for Q&A with the audience. So if you have questions, I encourage you to be putting those into the Q&A box all along the way. That way, as we get toward the end, we can jump right to them. As we get started here today, let me introduce our panelists. We have Dr. Shakib Shravi, who is the Chief Data Scientist for the National Technical Information Service, better known as NTIS, at the Department of Commerce. Richard Eng, Department Chief Engineer for Applied Software Engineering at the MITRE Corporation. Anil Chaudhry, Director of AI Implementations at the AI Center of Excellence at GSA. Dr. Michael Hauck, Data Scientist Consulting for the Department of Defense. Paul Moxon, Senior Vice President for Data Architecture at Denodo Technologies, and Ronald Smeltzer, Managing Partner and Principal Analyst at Cognilytica and Analyst Chair at ATARC's AI Working Group. So we don't have a ton of time, and we've got lots of you, and I know you all have a lot to say. So what I'm going to do is ask each of you to very briefly explain who you are, what those titles mean, and how your work relates to AI ethics and the proper use of these things. So Shakib, let's start with you.
Sure. Good afternoon, everyone. I'm Chief Data Scientist in the U.S. Department of Commerce, National Technical Information Service. The core of NTIS mission is to assist federal agency to leverage data as a strategic asset and harness innovative technologies to achieve mission outcomes. So we have a very unique authority that allow us to have direct access to joint venture partnership with the private sector and the industry.
Excellent. Richard, who are you? What do you do?
Okay, well, I'm the department chief data scientist, and most of my job is quality assurance and helping figure out whether or not projects are having difficulties implementing solutions. And more of these solutions are AI and learning enabled solutions. And part of the role.
Hey, Richard, we're having some trouble hearing you. Are you is your mic properly connected?
I thought it was. Still having
Well, then we'll
trouble?
let you. Yeah, we'll let you troubleshoot that real quick and see if you can get that fixed up, and we'll circle back to you for the end of introductions. For now, Anil, let's jump to you.
Hi, my name is Anil Chaudhry. I am the Director for AI implementations within the AI Center of Excellence in the Technology Transformation Services section of General Services Administration. In that role, I work with federal partners all across the government to help implement AI solutions and also work on AI solution strategy. So, in terms of taking folks' technical debt, taking their people debt, and then taking their process debt and figuring out a path forward that also aligns with the principles of AI ethics that everybody recognizes are important so that government can continue to deliver services as intended. Thank you.
Excellent. We'll be coming back to you to hear more about those efforts. Michael, let's hear from you next.
Hi, my name is Michael Hauk. I'm a consultant with the Department of Defense. I am a practicing data scientist. I'm charged with helping our agency develop a broad swath of artificial intelligence platforms and data services. And so, in order to do that, I've been looking very much at the key enablers for artificial intelligence, which include things like improved security architectures, but also improved data management and improved governance. And a key part of that governance has to be ethical artificial intelligence. Thank you.
Most definitely. I think even more so almost when it comes to life and limb and the things that DoD has to deal with. It's just that much more important. Though we're going to touch on all aspects of why ethics are important in this area. Paul, you're up next.
Okay, thank you very much. My name's Paul Moxon. I am the Senior Vice President of Data Architectures and Chief Evangelist at Denodo Technologies. In this role, I work a lot with organizations around the world, not just in the public sector, but also in the private sector. And within the public sector, it can be at the national or federal level, the state level, the local level. And I help them and advise them with their data and analytics strategies. What I'm really interested in today, this is going to be a great panel, is I'm really interested in hearing from my fellow panelists, their views on AI and ethics as it applies to them, and comparing that to how organizations, especially in financial services, in the private sector, are approaching these same issues.
Excellent. Richard, let's circle back to you. Let's see how your audio connection's doing. Richard, you with us? All right. So sounds like he's having some technical difficulties. They'll get that sorted out on the back end, and then hopefully Richard will be able to join us when he's able. So for now, I'd like to start off by going back to Shakib. I know you all have been working on a transparency and fairness report. Is that accurate? What are your findings, and what do you have to tell the rest of the federal space about what they need to know about ensuring ethical AI?
I think it's a critical question. The ethics. What happened with COVID-19 is that it kind of accelerated the adoption of technology and AI in particular. And now that we start like having a big appetite from federal agencies to use and leverage AI for their business processes, to modernize their approach to solve the problems that they have, they start to AI and ethical issues in particular. The federal data strategy, when it was developed, was very clear about a proper ethical use of artificial intelligence. So what we did at ACT-EAC is that we have created an AI playbook, a group. We worked first on trying to define AI and how it can be applied in federal agencies. The playbook has been published late last year. And at the beginning of this year, we started looking at the ethical part of that. So we are in progress. We have a white paper that is should be finished by the end of June. And interestingly enough, the next step is going to be to look at the workforce. So I think that's a good actually sequence because we need. I see the problem of ethics in the government and in enterprises in general like a cybersecurity issue. The first step will be awareness, is to develop awareness about the ethical issues, etc., and then prepare the workforce as part of the development and the design, as well as the use of AI on the other side to look at the outcomes, to be knowledgeable about the AI ethics and the AI issues that come from that. So that's going to be a very important way to look at them.
Right, because you have to look at that from the very beginning, right? The ground up, who is developing and who's using these systems, if you're going to be talking about the ethics. Also, I have to jump in here and say I was remiss in my all excited to get started here and talking on the subject. I forgot one of our panelists. Ron, I was going to actually go to you after Shakib, so this works out. Briefly, explain who you are, what you do, why you're joining us for this panel. And if you could, I know you're part of the ATARC AI working group. Can you help us level set on some of these issues as we get started?
Yes, hi. Thanks for including me on the panel. So I'm Ron Schmelzer. I'm a managing partner and principal analyst at Cognilytica. Cognilytica is a research advisory and education firm focused on AI and cognitive technologies, machine learning. And we cover the market, spend our time looking at research covering over 8,000 vendors in the space, as well as research on adoption patterns for AI. And we were actually one of the forming members of the working group for AI at ATARC. We're spending quite a bit of time looking at transparency in particular, and the transparency assessment, which is a way to understand when you're looking at a machine learning model, how much transparency do you have as to what visibility do you have into that model? Do you have visibility into the data? Do you have visibility into the training? Do you have visibility into the algorithm? All these different considerations before you consume a model that was produced by someone else. To what extent can you have visibility into it? And that's part of what we worked on as part of our ATARC working group on this transparency assessment.
Excellent. And then let's just take a real quick aside. Richard, were you able to join back in? Doesn't sound like we've got him yet. If you are able to hear us, Richard, and you get back on, just pipe right up and join the conversation, and we'll welcome you with open arms. So, moving on with the topic of today, right? Ethics in AI. Ron, you brought up a very interesting point about the black box issue, right? How do we see inside what's being developed? And I'd like to go to you on this as we start off. As federal agencies are thinking about this, and they're buying and developing in-house, they're using contractors, third-party services, whatever mix they're doing. How do you ensure that, one, as the agency, you can see inside how it's being developed, and two, how much transparency should you give to the outside world depending on what you're working on? Should every AI system be completely transparent?
So that's such an excellent question. So first of all, I would like to say that, I'm very fortunate that I have peers such as Shakib, Rob, Ron, and Michael working with me. We've been working on AI transparency for the last year and a half or so, right? And I also have some really good partners, my peers in the centers of excellence and in TTS. Steve Babich, Krista Kennard, who I think everybody just heard from recently. I've been working with a lot of folks in ACT-AIC and ATARC and in the federal AI community of practice to deal with this very issue, right? Is that AI represents the forefront of government and technology. And there are times when the government doesn't need to be on the bleeding edge of things. It's okay if you get a X on Facebook that says people you may be consider being friends with, but that sort of matching algorithm is completely unacceptable when you're talking about no-fly lists. So practical implications of the power of the government that need to be considered in AI. And we
So
start from that.
I could see that ex Facebook thing working out well for like a past performance or like re-upping a contract, right?
That too, yes, right? So, we talk about this, that there needs to be transparency in the AI model. And to your second question, even though there's transparency in that model, does it need to be transparent to the public? Those are two different questions. So, as to the first question, as a federal employee and someone who helps roll out federal programs, transparency is absolutely critical. If we don't know how the machine is helping make those decisions and augment a human making those decisions, we can't explain it to our stakeholders, Congress, other folks that may have a real interest. But, just like we have methods and procedures in law enforcement, we don't share them. Everybody knows where they are, right? And if we have to go back and trace a decision, we can do that. That's really where transparency in AI lies, is that we should be able to walk back a decision and be able to replicate the same decision with the same decision points. So, we have to be very transparent, but, you know, uh, do we need that level of transparency when facing the public so that, our algorithms are not gamed? So there are two different questions, many broad implications, but it goes back to your core point that as somebody running a program, I need to know exactly how the program is running. Thank you so much.
Yeah, no
I've
problem.
just got
Richard, it looks like
sorry, just a couple of things there to follow up with Anil.
yeah, sure.
First of all, I agree with him. There's two aspects to this. There's transparency, which is internal transparency, and then there's explainability, which is to the public. Explain how the data is used, how that decision has come to, without necessarily giving the details of the algorithm. So I agree with that, but my question is, how do you get the transparency internal when sometimes some of these algorithms are just so complex, especially if you're using unsupervised learning? I mean, you're actually saying, I don't know how to get to the answer. Please, machine learning algorithm, neural network, get to the answer for me. You need really smart people for this. And, they tend to get paid a lot of money, and usually by financial institutions who pay them $500,000 a year to do credit scoring and things like that. So how do you do this in the federal agencies with limited resources, limited budgets?
So a suggestion for that, and it's not a complete answer, but standardized training sets is one element that would help here. And so if we have training sets, just like an open source software, we have open source training sets, not for everything, but in many cases we could. Then people can examine those data sets for inherent bias to begin with, or with respect to our societal values to begin with. And so we talked about transparency, and this is one of the things that, for example, last summer NIST looked at in an AI standards workshop. So there are a lot of efforts going on, but I think it's a very early stage. I think there are a lot of incomplete answers.
Yeah, it's an interesting option, Michael, you pointed out. I heard a CTO from a top federal vendor once floated the idea by me of similar to the way China is able to federalize all of their AI training and data and stuff like that and move faster in that way. One option would be to basically, like you said, open source the training data for training data sets for use here in America. So then the IP lies in the algorithms that come out of it, not in the data sets. Those become free to use, which could be an interesting way to go forward. Richard, I see that you are back with us, so I want to jump to you and just real brief, because we couldn't hear you before, brief introduction, and then feel free to jump in on this topic about the right level of transparency.
I think transparency in terms of interpretation of the models and the results are critical in terms of ethics for AI applications. And that's one of the things I wind up doing quite often in looking at the AI machine learning enabled solutions. Can we interpret the results that we've gotten? As one of my fellow panelists mentioned, some of these algorithms get to be very complex. One of the things that I usually do is I build decision trees just to bounce off the results to ask, okay, do I have some clue of how it's arriving at the answers? And is it basically picking features that may be biased? And I've seen that over and over again in the commercial sector, that AI and machine learning are wonderful, but they tend to pick up the biases that we've had inherently that we may not have been aware of in the data sets. You know, I'll point you guys to Amazon when they were trying to come up with an set of algorithms to hire the top 5 candidates on the internet. And it was quite interesting reading the various papers on that. Over.
Yeah, it's a classic problem, the garbage in, garbage out problem that we have with AI, right? If your data's not good, your results aren't going to be good. But Ron, let's start with you on this particular topic. How do you know when your data is no good, especially if you're grappling with internal biases that you're not even necessarily aware of, your team biases that you're not necessarily aware of? I think it's worth mentioning at this point as well. If you look around our screen, you'll notice a lot of men, right? So if the leadership is largely male, how are you ensuring that your teams are well balanced and you're getting all those perspectives? How are you managing all that?
Yeah, so I think part of it is the issue of knowing about the bias of some data sets, as well as you mentioned, our dependence on, you said garbage in, garbage out. And you're right, machines can only learn based on the data that's being fed. And also the issues of selection of data. And a lot of times we have very little visibility into the decision-making process by which the machine learning has actually come to a decision. We may know the probabilities, we may know the configuration of the neural net, we may know various different factors, random forests. We may know those factors, but we don't know the specifics for a particular decision, perhaps. And so one of the things that we've been trying to address is that, well, even if we don't have visibility into the specifics for a particular algorithm, if we can gain enough insight into the data that was used to create that model, then we can basically make a decision for ourselves as humans as to whether or not how we will use that model or how we will weight that model. For example, we may not necessarily care too much if we have an unsupervised learning model that makes product recommendations and it says, when I purchased a tent, I might be interested in a sleeping bag, or maybe I'm interested in marshmallows. I'm like, okay, I'm not sure how it came to those conclusions, but those are perfectly adequate, and I don't really need to interrogate the model too much. But we may have another model that's providing some sort of predictive analytics or prediction and says that based on whatever factors, I should not be granted a loan for a specific amount of money, or perhaps some other decision about parole or a facial recognition thing. And then we are left with a question, which is, how did the model arrive at this decision? And even if we can't inspect the algorithm, we might say, well, let's look at the data. You know, can I have visibility into the training data? Can I have visibility into how you selected which data to be used in the model? Can I have some visibility into the parameters and the configuration, the hyperparameters? If you can provide some of that visibility, while it may not help with the explanation, it may say, oh, I understand. We used this data and you selected this kind of data. Therefore, there might have been some biases in that data, or maybe the method that we had used to select it was not rigorous enough and we excluded data that we should not have excluded. So this is one way of addressing that challenge, perhaps.
And could I add just one thing, too?
Yeah, by all means, Michael.
Go ahead.
Oh, no, Michael, go ahead. You want to jump in?
Well, I was just going to say, and then some things, I don't think it's up to machines to be making the decision. Why would we want machines to be making parole decisions? Why would we want machines to be making sentencing decisions? I mean, ethical AI is also about how we apply AI to what types of problems. I mean, Ron was talking about this, but I just want to pull it out explicitly.
So,
Yeah,
Aaron, I do want to jump back to Paul's earlier point, because I think it's important. You know, back in, and I'm sort of like that Warren Buffett type of philosophy, right? If I don't understand it, I don't invest in it. And it's that, in 2008, we thought all these folks were really smart. And then when the market imploded, their CDOs, CBOs, and all this cross thing, financial engineering, this fancy financial engineering, which was a house of cards, right? And we go back to, the AI models. If the AI model needs to be that complex to solve a problem, maybe that model is not the right model to begin with. So I'd leave that with folks. Thank you.
Interesting.
I think it's very important to point out that the bias mostly in machine learning models come from the data, as was pointed out earlier, as well as from the algorithms. But those are very complicated to deal with. There's no easy solution. Actually, if you look at, for instance, the algorithm, the most common form of machine learning that is used is supervised learning. So what you need is labeled data. So the labeling can bring in bias. Of course, the representation of the data can be not completely diverse and represent the actual population. And the other problem is that the AI can exacerbate the bias. There is, for instance, an example of what's called the feedback loop. So if you have any issue, for instance, a problem for applying for a loan, and then you have three groups: Group A, Group B, Group C, and they have like a rate of not be able to actually pay back the loan. Let's say 10, 15, 20%. Then the artificial intelligence algorithm will go, of course, with Group A because there is less risk. And then if you do that, then maybe 1 year later, that Group A rate will go down to 7%, but the Group B and Group C, which are going to remain at 15 and 20. So this is what's called the paradox of AI algorithm. On the other hand, also the fact that we always think in machine learning that more data, the better. But in terms of risk management, when you deal with ethical concerns, the more data can create more liability for you and more risk for you. So this is where companies have to be very careful to develop a proper framework that deal with with a comprehensive view of all the ethical issues as well as the technical issues.
So, Shiva, I'd like to stay with you for a second and talk about some of that life cycle of those ethical decisions. Obviously, I think it should be obvious, right, that you need to be making the considerations the entire way along, right, from the beginning to the end and a constant refresh. But which parts along that line are of particular interest to particular federal audience? Do you need to have a task force to review all your data before you buy it or you ingest it or whatever? How do you set that up? What's the best way for other agencies to do that?
Myself, what I would suggest is a framework that has 5 phases. The first phase is what we're doing now, is awareness. We need to learn more about the AI and the ethics and the issues that are there. Because as we're trying to develop very quickly AI solutions, which give us a lot of opportunities for federal agency to actually save money, be more efficient, more effective, we need to be careful about how we go about that. So the second phase is to identify the intent of use, the purpose, because not all bias is bad. So we need to find out exactly what we're trying to accomplish. And the third phase is the design. When you design a solution, and the IEEE has developed a gold standard that we have to look at that explain exactly how any company, any enterprise can go about it by including a very diverse group in terms of very representative from cross-functional in terms of the enterprise, but also representative about the problem at hand. So you can see the different perspective about that and understand. And of course, you're going to have to look at the data and methodology and make sure that you debias the data and you use a methodology that's as transparent as possible. And then you have the outcomes. So you have to keep monitoring the outcomes. The interesting about AI models is they are living software. They're not like a regular software where you have some kind of stable form of it, and then it's just you just change it by creating new releases or new versions. AI is an iterative process, so you have to have a good monitoring of what's going on and try to understand if there are issues there that you have to address, as well if there are good things coming out of that system as well.
Excellent. Ron, you look like you wanted to jump in here.
Oh no, definitely. I think people are on the right page here. We need to be thinking about this idea of transparency and ethics kind of more broadly, especially this idea that there are some instances where you do want systems to have. The word bias is unfortunate because it's very overloaded, especially in the machine learning context. It has three completely separate definitions. We have the notion of bias that the typical person might think of, which is this, cognitive bias, your informational bias, the bias that you have as a human because your brain likes to make shortcuts. I mean, that's the bias we have. But then in machine learning, we also have this idea of the bias-variance tradeoff, which is a whole other kind of bias, which has to do with overfitting and underfitting of models. And we have a third notion of bias that has to do with the bias in weights and biases in neural nets, which is a completely separate definition. It's unfortunate the English language is overloaded like this. But there are some kinds of bias that we do want. For example, you might say in certain insurance situations that there are reasons why there are differences in health insurance coverage in men and women because there are different conditions that men and women have, for having different body parts and things like that. You may have biases in age, older people versus younger people, smokers versus non-smokers, drinkers versus non-drinkers. And these are okay, even though they're informational biases, because they may be important. I think the important thing is it's when the biases are not important and cause these other effects that are unintentional, that's when we have these issues. So I think understanding bias in that larger context and maybe finding a better English word for it, but I don't think that we can, would be nice.
Yeah, we need a four love for bias.
Yeah, actually, just to that point, I have seen ethical frameworks for AI where they talk about justifiability. And I think that's what you were getting at, Ron. A bias can be justified, and it's okay. Like you said, you can justify age for health insurance, etc. So as long as it's explainable and it's justifiable, there's nothing wrong with bias. It's a very positive thing if it's used in the right way. It's when it's inadvertent bias through your data set that you're using for training or the algorithm, that's when we get into trouble. I mean, one question I do have for the panelists, just because I've been working with the private sector as well, is who do they think should be the, for want of a word, auditor for transparency and explainability within your AI systems? Should it be IT? Should it be broader?
So I'll take that on because I've been thinking about that and working on that issue a little bit. And it's a people process technology problem. That's how I always view things, right? And we start off with, as we peel the onion and we start to learn more things, the government adjusts. So the Evidence-Based Policymaking Act was a huge step in the right direction, with CDOs at each agency and understanding the strategic value of the commodity called data, right? And how to, and I hate using the word monetize it, right? Because the federal government isn't about pure profit and loss, but it's about taking this data, and when I say monetize, what I mean is deliver better, more effective citizen services. So we start with that. I'm sorry?
Operationalize it.
Yes. So when we talk about these issues, whether it's a CDO, whether it's, it's understanding where everything fits in and still in flux. So, I think it's too early to start, empire building and saying CDO is going to have this, CTO is going to have this, COO is going to have this, CMO is going to have this, because then we won't get anywhere. It's right now place is still too fluid, and we really need to first of all understand not who owns it, but who's the belly button when something goes wrong, right? That's the first thing we need to identify. That, when my personal health information is released because somebody misconfigured a database on the cloud, whose head gets lopped off, right? And once we start working on those issues, then we can start working on the empire building after that. And that's just, my personal take on it in terms of, what it means to be an ethical government when playing in the AI space. Thank you.
Yeah, I think to Paul's question, that was an excellent response because it does get into some of the nuance here. But it makes me think of there's a couple of ways to even break out Paul's question, right? You can talk about who's responsible for specific outcomes, but I'm willing to bet that GAO's relatively new STAA office is going to be checking in on the ethics of some of these algorithms as they get published too, and who's going to have the resources, the expertise, and the ground knowledge to actually dig into all of these. Richard, that's actually something I wanted to go to you about and frame that question with regard to the workforce. When you're building the teams that are going to build and buy these systems, who do you want on those teams? What kind of backgrounds, demographics, education, ways of thinking, diversity? What are you looking for in your workforce to develop AI?
So you want a multidisciplinary team. You want software people, people who are familiar with AI and machine learning, but you also want people who are domain experts. And that's where I find a lot of the projects seem to go south originally. Because just because I get a machine learning result or an AI result, can I interpret it? Does it make any sense from a pathophysiology perspective? We've had many projects where we've gotten a great result only to find out that it was how we did the feature engineering and the selection of features. We don't want to use the word bias, perhaps the feature engineering went awry. And once we went back and looked at the features and said, you know what, interesting feature, but it really, even though it gives us a good signal, it's really not relevant to solving the problem. And to get back to the other issue about ethics, are we doing a prediction or are we looking for insight into the problem? And that's the standard for ethics and accountability is going to be very, very different. If I'm exploring the data at hand to try to gain insight into a problem, that's one thing. I can afford to be off with the features that I use and I decide to exclude. But if I'm using those features to make a decision, as one of the panelists said, make a credit decision for somebody yay or nay, or worse yet, decide who do I send credit card offers to because I want to maximize my profitability because I have a certain budget to send out mailers for credit card applications, but I want to get responses from people that don't pay off their balances each month so that I can collect the 18 to 22% interest. That's an ethical issue. Is it illegal? No, but it's an ethical one. So who arbitrates that? Is that part of the federal government? Is that part of the company? Is that the IG office within my organization? It's an interesting topic. It depends upon your problem domain. So I'll kick that back to my fellow panelists who are itching to answer that as well.
Yeah, I'm sure. Yeah, this also reminds me of a specific problem in AI with regard to facial recognition, right? So there's for those who aren't necessarily that deep in the field, there's really two main kinds of facial recognition being used, particularly by federal agencies, and that's the one-to-one, where, for instance, CBP, when you're entering the country, they're going to take a picture of your face and they're going to match it to your passport photo, right? Does this photo equal this photo of the same person? Versus one-to-many, which is, for instance, like what they're looking to restrict in the policing reform bill right now in Congress, which would use facial recognition to look at a person and say, who is this person? And try to identify them against a whole gallery of pictures, right? When you get to that second one, that's the predictive one that just is a lot harder and where you run into more of those ethical issues. So, Rich, I think that goes right along with what you were saying. I wanted to switch next to our two data scientists by title. I know all of you have expertise in this, but Shakib and Michael, I want to go to a question to you. I also want to remind everybody in the audience, we're getting toward the end of our program, and I don't see too many questions in the Q&A. So if you have questions for these gentlemen, please get those in now. So the next thing I wanted to focus on was sticking with this workforce angle. Who do you need in place in leadership to make sure that what's being developed and bought, that these bias questions and ethics questions are being taken into account? Starting with you, Shakib, as a data scientist, who do you like to see in charge of these AI projects?
Well, I believe that it's very difficult, by the way, to solve, because I can give you an example first before answering your question, is that last week I had a meeting with actually a representative from a very big company. And then I asked that question about how you're dealing with the AI ethics. And they said, well, we have a committee. And then we go over every project and we try to have a multidisciplinary team, cross-functional team that look at it from the technical part to the operational phase, to the legal phase, and also the social. Computer vision and image recognition for multi-purpose use. So surveillance to
Unfortunately, we're only getting every other word. It sounds like the quality of service AI on this platform isn't quite managing your audio, because we're only getting every third word here. So forgive us, Shakib, because we are coming low on time. So I'm going to just switch over to Michael, and hopefully yours settles out as we get into the Q&A here. Michael, similar perspective from a working data scientist. Who do you want in charge of these programs?
Well, first of all, I'm sure I would agree with everything that Shakib said, because I wish I'd heard him. Right perspective. And where I see it, actually, our leadership is very visionary and sees the promise. Where we have the challenges, at least where I sit, is in our workforce and how we go about implementing AI. And so that has to do with a lot of the enabling elements of it. So we can easily go out and purchase some AI software, or we can bring in some coders and code something up. But when we try to systematize AI and put it throughout our entire enterprise, there are a lot of disciplines involved in that. Everything from the security people who allow the software in the networks and allow it to run, to the policy people. So, for example, a privacy office. I'm a close partner with our chief data officer because to treat data as an asset, we also have to govern it. So it's a very holistic thing because it's a paradigm changing sort of thing. I guess my point would be, we don't just take AI. Management has to understand, you don't just take AI and add it to the toolbox of things in your organization. It actually requires a re-engineering of how software and systems are done. Not just software, but the information, the networks. It's the whole thing.
I'm going to try to reduce that fantastic, nuanced explanation down to a multiple choice answer. If you had to put somebody in charge of an AI program, development, buying, the whole shebang, do you want a PM? Do you want a data scientist? Or do you want an ethicist?
No, I want a data scientist. The reason I say that is the data scientist, to me, has all of these skill sets.
Excellent.
Okay, can I question that?
Oh yeah, Paul,
I could question that. Yeah, I could question that because I work with financial services. I work with banks as well. And the people who raised the ethics issues in banks, the original ones, were the legal and compliance team, not the technologists. The technologists want to push the boundaries. They want to do what they're really, really good at, but they don't always think of the inadvertent consequences of what they're doing. They're thinking positive. They're trying to do something good. They're trying to do the best thing. And sometimes it's thinking beyond IT. And the financial services, it was the lawyers and the compliance people who always started to raise the ethical issues and started to put the ethical programs in place around AI, not the data scientists.
Which is unfortunate. And so we look at when we look at, say, the Department of Defense's 5 principles for ethical AI, the first one of those is called responsible AI, and it places the responsibility in the hands of everybody involved, from the end user to the developer. And I think what we need in terms of an educated AI workforce is a workforce that is educated in at least some of the fundamentals, including ethics.
I would agree with that, Michael, but sometimes the data scientists don't necessarily always have the vision of how something can be abused. Not how it's used, but how it can be abused.
Aaron, I was actually going to go with option C, just to be difficult.
Yes, I agree.
And, I think it's got to be a strong program manager with common sense. That's really what you need, that can help bring together the data scientist and the compliance folks. The data scientist wants to really take a risk, and the compliance person wants no risk. And somewhere in there, the program manager has to balance that in order to deliver a capability. And I think you had a ton of questions. So, yep. So, I think you had a ton of questions. So
We did.
Shut
we
up.
have a we we have a few questions. So I think this is a good spot to transition. Sorry, I see a few of you. Oh, Richard, did you have a burning point you needed to jump in on?
I was going to say the last person I would put in charge of one of these projects is the data scientist. I would rather pick, honestly, an informed business owner that understands the domain and the context and the consequences, the true consequences of the wrong answer. And in finance and banking, it might be the compliance regulatory folks. In medicine, you really want that domain expert of a doctor, whatever the specialty. And I've run across this over and over again in medicine. From a data science perspective, hey, great. Sensitivity, specificity, accuracy, 90% plus, great. We just won the Nobel Prize. Well, no, it makes no sense from a pathophysiology perspective. Oh, maybe we picked the wrong features. The signal are wrong. You need that expertise to push back against the data scientists. Over.
Well, I'm Ricky, but just quickly. No, he said data scientist. I have to defend the data scientist here. But Ricky, I think the data scientist will be able to give you an insight about how bad it can be using a machine learning model.
Yes,
so what I'm hearing actually is this is answer D, which is all of the above. You need to find that unicorn that can do everything, because otherwise we're all screwed. So let's go ahead.
You got to pay them $7.50 an hour. All
right. So first question:
it has to be a data science team.
When we're speaking of automation for human resources, for example, doesn't that sacrifice excellent candidates that do not have the correct match the algorithm uses? Don't we still need the human factors to catch what an algorithm misses? And isn't that a worry of the industry? Scientific research uses the models, but we can't validate because biologically we can test it. We can see it. But I don't see that in these everyday predictive analytics. I think it's a very interesting question. How do you merge? If we're putting so much reliance on these algorithms and machines to do the work for us that we can't do, how do we, as humans, make sure that those catch-alls are working? And I'll go to you first.
Yeah, I'll take the first stab as a hiring manager, and I'll tell you my challenges, right? It sort of goes to this question. When I put a job announcement out, we have a standard platform to put an announcement out, and the bureaucratic friction to get an answer is just one click. And for that one job, I'll get 1,700 resumes, and barely, probably I'd say 50 of them are qualified, right? It's just because the ease of pressing the button says, yes, I'm the expert in this, I'm the self-designated expert. So, there's that separating the wheat from the chaff. And what I tell people in a problem like this is that if you can't follow the directions on that platform, and answer the questions you're being asked, maybe that's an indication of your ability to stay in that job. And I'm not being glib about it, but once you do get the group of candidates, what I have always done, and I've encouraged my teams to do this, as a third line supervisor, is you look at the group of candidates and say, who am I missing? And then you have to go back to your human resource folks and say, why am I only seeing folks from Ivy Leagues, for instance, and not to, pick on Ivy Leagues, but just that. Or you say, why am I only seeing males? Why am I not seeing, that mix? Why am I not seeing veterans? You got to ask for that, and you may have some rational answers, but what you need to do is you as a leader need to take charge and ask those hard questions on why you aren't getting the things that you need, that sort of resemble society, right?
Yeah, you mentioned
You
before,
should get
right?
an applicant pool, yeah, and
You
that's
mentioned
really
before
where
people,
I'm
process,
sorry.
and technology.
Yep,
You mentioned before people,
and
process, technology. It's got to go in that order, right?
Yep, and that's where it goes back to if I'm not providing feedback to the people that are developing this algorithm, it'll continue to give faulty outputs. So that's where it goes back to if I'm not questioning the output on that you just gave me a crappy list, why? It's never going to get fixed. And with that, I'll defer to my esteemed colleagues, especially in the data science field, who can articulate more on this subject. Thank you.
Unfortunately, they're not going to be able
Yeah,
to
if I can,
articulate more on this panel today because we are running out of time. We
okay.
were told we can go slightly over, so I am going to ask this last question and leave it to one person to give an interesting answer here. Are you deploying AI systems in an environment where they have to be certified for operational use? How do you certify them? Standards, test and eval, etc. I'm going to modify that question a little bit. In the federal space, do we need or have an ATO process for ethical AI?
Not yet.
Well, it's still, yeah, not yet. It's still in the process. OLB just did a request for information.
We're losing your audio again, Shakib, unfortunately. But it sounds like you
So it
said
sounds like you need one, but you don't have one.
but I heard an RFI, so it sounds like the process is coming. So stay tuned to NextGov because that's something I'm going to be following up on you with. I want to hear more about that. But for now, we're going to have to sign off on this panel. Thank you all for joining us, and thank you all to the audience for your great questions. Sorry we weren't able to get to more of them.
Thank you. It's been fun.
Thank you,
Bye,
everyone.
Thank
everybody.
you. Thank you.
Hello and welcome to this tech talk called Real-Time Interagency Data Sharing with Data Virtualization. My name's Paul Moxon. I am the Senior Vice President for Data Architectures and Chief Evangelist at Denodo Technology. I'm going to be your host and entertainment for the next 15 or so minutes. In this session, I'm going to talk about how government agencies can accelerate and simplify the sharing of data, both within the agency and also with other government agencies, whether it's at the federal, the state, or the local level, by using data virtualization. I'll also talk about how a national government agency, the National Health Service in Scotland in this case, is using data virtualization to share data in this way, and the types of projects and data sharing that it's been able to actually perform. Finally, I want to talk about a great example of how data virtualization can quickly and easily access data from many different agencies, in this case from around the world, to provide a data portal where users can come and access the data that they need. This is Denodo's coronavirus data portal, and we'll talk about this a bit later in the session. Now, I'm sure you're all aware of the challenges of sharing data both between agencies and often within the agency, within different departments within a particular government agency. There are technical challenges about the data being in the different formats, having different meanings because they have a different taxonomy, etc., different security requirements, and so on. There are also issues and concerns about data ownership. It's my data. I need to control it. I need to look after it. And if I give it to you, then I might lose control of my data. And that is also something that we see in data security and data privacy compliance. For example, in health and human services, having to conform and comply with the regulations around, say, HIPAA for patient privacy, etc.
And also, how is the receiving agency going to use the data? If I give you this data, how are you going to use it? How do I know you're going to use it in a way that is appropriate for the data and the privacy and the confidentiality of the data, etc.? And often, interagency data sharing is using what are relatively antiquated methods of dumping data into a file and then transferring it across every day, every week, every month, etc. And that has its own challenges. For example, in Australia, there's a state organization there, the Office of State Revenue, which does a daily transfer to its sister department, which is the Department of Treasury and Finance. If anything goes wrong with those transfers, they have a team of data engineers who have to go and fix them, because the next day's transfer is not going to pick up yesterday's data. It's only going to pick up that day's data. So they have a team just fixing broken file transfers, and this is not obviously very good. So we'll look at data virtualization and how data virtualization can help. But before we do that, let's talk about what data virtualization is. And Gartner have this definition of data virtualization. It says that data virtualization is a technology that can be used to create virtualized and integrated views of data in memory rather than physically copying the data. So in other words, the data stays where it is and it's retrieved on demand and presented to the user. So the owning agency is actually keeping the data. They're just allowing people to come and get it when they need it. So I'm not suddenly giving you all my data. I'm just opening the door and saying you can get some of the data, but only the data I'm going to allow you to get. And also provides an abstraction layer on top of the physical implementation of the data. Now this is great because it decouples the two parts of the equation. It decouples the owner of the data from the user of the data. Now I can control my own data. I can do what I like with my data. But I'm giving you that doorway, that gateway into the data so you can get what you need, but I'm going to take care of it. And when you come and get what you need, you can use the tools that you need. You don't have to comply with what I'm saying about you have to use this tool, I'm going to transfer the data in this format, etc. So it's a great way of decoupling the owning of the data from the usage of the data, leaving control with the owner. So if you look at this a bit deeper, data virtualization is this layer that sits between the data and the consumers of the data. Could be the other agencies, could be departments within the same agency. We have this mantra: connect, combine, and consume. Connect to the data sources and create virtual views. Combine the data, define how the data should be combined, integrated, transformed to create the data view, the virtual view of the data that the user actually needs, and then expose that to them so that they can come connect to the data virtualization platform and get the data that they need. So again, what data is available and accessible is controlled by the owner of that data. The consumer of the data, the other department, the other agency, etc., can choose how they're going to get the data, but they can only get to the data that they're allowed to get to, that they need to get to. So if we look at this in a bit more detail, go back to the same diagram, the data virtualization platform between the data and the consumers. You connect to your data sources, you create something called, in Denodo terminology, called base views. These represent the underlying data entities, but it abstracts away all the complexities of where the data is, what formats it's in, etc., what authentication mechanism I use to get to that data. That's all abstracted away by those base views. So those base views become reusable building blocks. I can now combine them together to create something until I eventually get something which is meaningful to my users, whomever they are, inside the agency, external to the agency, etc. The users can then connect to the data virtualization platform. It's almost like this data access layer, this data gateway. They can connect to the data virtualization platform using the tools that they choose, using the tools that they're familiar with. So if I want to combine claimant data with payroll tax data, maybe I'm looking for people who are doing fraudulent claims on workers' compensation benefits or something like that. I can access it from the tools that I'm familiar with. could be a reporting tool like Tableau or Power BI, and I request the data virtualization platform will go and get the data that I need from the underlying data sources and actually return it back up to me as a user. The data virtualization platform doesn't keep a copy of the data, it just gives me the results, the data I need. The data stays in the data sources, so I'm not physically copying the data, under the control of the owning agency. So, in a nutshell, data virtualization platform allows you to connect to your data, allows you to define how that data should be integrated, transformed, combined to create something that is meaningful to your users, whether they're internal to the agency, external to the agency. And then those views can be exposed and using a number of protocols, formats, and the consumers, the users of that data, can connect the data virtualization platform using their own tools, their preferred tools, to get the data they need. But we're not physically copying the data. They're just getting the data, retrieving the data they need when they need it on demand. So that's that snapshot of what data virtualization is. Government agencies using data virtualization, they run from federal agencies, state, local government agencies, national agencies throughout Canada, yes, Canada, as well as the Europe and the Asia Pacific region as well. So a broad swath of different types of different levels of agencies using it to share data inside the agency and also external to the agency, inter and intra-agency sharing. If we look at an example of one of these, National Health Service in Scotland, they use the data virtualization platform to share data both intra-agency within the organisation, within National Health Service Scotland, and also with other government agencies. So they're sharing data with regional health authorities, with hospitals, with research centres, etc. But they're also sharing data with other local authorities, with the emergency services such as the police, central government like the Scottish Parliament, etc. And you can see some of the use cases on the right hand side that they have implemented using data virtualization to allow this data sharing. An interesting one is the PARD project, Persons at Risk Distribution. The NHS, National Health Service in Scotland, keep a list of what they classify as persons at risk. These could be persons with mobility issues, they could be people with mental health issues, they could just people who are living alone and are vulnerable, maybe they're old people or something like that. Now, if there is a declared state of emergency within Scotland, declared by the First Minister in Scotland, the emergency services have a statutory duty to do a health welfare check on these persons at risk. That's the only time they can get this information. Now, instead of waiting for the National Health Service to send them a list, they can actually come and get it themselves. They can connect to the data virtualization platform, this data gateway into the National Health Service data, and they are allowed to get to the persons at risk list for their region. So the Strathclyde Police can only get the persons at risk list for their particular region, which includes Glasgow, for example. The Edinburgh Police can get the persons at risk list for Edinburgh and only Edinburgh. So it's controlled what they can see to protect the privacy and the confidentiality of the people on the persons at risk list, but it allows the emergency services to fulfill their statutory duty to go and do health checks, welfare checks on these people in a declared state of emergency, such as the recent coronavirus pandemic. Within Scotland, the health services, the emergency services actually did welfare checks on all the people on the persons at risk list to make sure they're okay, make sure that they were getting the groceries, etc., that they weren't in any trouble, weren't overstressed or overwhelmed by the ongoing pandemic. So a great example of inter-agency sharing within the National Health Service in Scotland. Now, the last thing that I'm going to talk about in this tech talk is a great example of using data virtualization to very quickly connect to authoritative data sources in government agencies, in this case around the world. And this is the Denodo's coronavirus data portal. The data portal is actually an open data portal allowing users to access coronavirus data from around the world. So they can come here, and it's not just the usual information about coronavirus data, such as number of cases, number of deaths, number of hospitalizations, etc. It's also information about the government's response, whether it's at the state or federal level, the government's response to the coronavirus pandemic in terms of restrictions on number of people in meetings, to shutdowns, etc. Also, the socioeconomic impact in terms of unemployment claims, etc. So all of this information is available through the data portal, and it's free for people to access and use the data. We actually connected to 63 different government data sources, mostly government. There are some non-government agencies in there as well. 63 authoritative data sources from around the world, tagged and collated the data, categorized the data so people could go and find it and search it, etc. And anybody can go to the coronavirus data portal and go and browse the data, have a look and see what's there, sample the data, download the data, or they can connect with their own tools to build dashboards, etc. And we do have some users who are building back to work dashboards, sort of like decision guides for management about who should go into the offices when their state economy actually opens. You know, who is coming from areas, counties with high incidence of cases, where the office is in a county maybe with low incidence of cases. Should those people be traveling to the office like that, or should they stay and continue working from home? So it's a great tool for anybody to use. And we've connected, like I said, to 63 different data sources, and you can see the list here of all the data sources, including things like United Nations, the World Health Organization, Department of Labor, for example, obviously things like Johns Hopkins University for their coronavirus data. The New York Times is another one that we've connected to. But you can see at the state level, there are things like, the state of California, Health and Human Services, state of Texas, state of New York, etc. Down at the local level, New York City, Department of Health and Mental Hygiene is another one we've connected to. So a broad swath of agencies from around the world where we've connected to them using the data virtualization platform and provided this data portal based on the data virtualization technology. There is a data catalog where people can go in there and browse and look at the data, and you can connect to the data portal itself using tools, like I said, to build dashboards, include the data into applications and stuff like that. So that's a great example, because we had a small team of engineers actually connected to all of these data sources in just a couple of weeks. Just a handful of engineers, and built out this data portal. And if you do want to go and look at the data portal, coronavirusdataportal.com is the URL that will take you to a landing page. If you scroll down a bit there, you'll be able to actually go and click on a link which will take you to the data catalog, where you can go and browse the data to your heart's content. And with that, thank you very much for attending this tech talk. I hope you found it interesting, and I hope you found it valuable. Thank you very much.